Okay, what we're going to do today is integration by substitution. So can you put a title, please? Integration by substitution. Okay, and what we've got here is a question that you don't know how to do yet. I've asked you to find the integral of x square root of 2x plus 5. Why can you not say, let's try adding 1 to the power? Why can't we try integration by recognition? Yes. Yeah, because if you think about it, if I said try adding 1 to the power, in your bracket you got 2x plus 5. What does 2x plus 5 differentiate to? 2. I've got an x, that's my problem. I can't just say, oh, let's multiply by x. Okay? So you cannot use integration by recognition. In almost all examples, they will give you the substitution, unless it's really obvious. So here I've told you the substitution. I would like you to use this substitution. U equals 2x plus 5. Okay? Can you just get you to write the question down, and then we'll go through it step by step. There's some key sorts of steps you just have to take here when you're doing these questions. So I'm going to move this up to the top so I have some space, but the title's gone. Okay. The first step, and they're written down over here, okay? I'm going to work out what the integral of that is. My step number 1 is to figure out, is to make the substitution and find out this thing called du by dx. Because essentially, what I'm going to do is I'm going to say, okay, I can't do this integral with x. I don't know how to do it. But what I'm going to do is I'm going to convert it to another integral with u that I do know how to do. I'm going to do that integral. And then I'm going to say, let's go back and convert my u back to x. Does that make sense? That's the logic, okay? I've got an integral I can't do. I don't know how to do it. I'm going to use a substitution. I'm going to convert it to an integral with u instead of x that I do know how to do. I'm going to do that integral. I'm going to figure that integral out. And then I'm going to say, well, hold on. I can't leave an answer in front in u. I've got to convert it back to x. It's like me saying to you, like, you know, what's the distance in miles from here to London, central London, and you measure it in kilometers. You can't give me the answer back in kilometers. You've got to convert it back to miles, right? So basically, that's what I'm doing. A simple sort of translation into something that I can do. I have to convert everything out. So if I told you u equals 2x plus 5, could you easily tell me what x is? You can all rearrange that, can't you? Could you easily tell me what 2x plus 5 is? Well, 2x plus 5 is just u. But I have to change everything. And everything means this thing. I have to change this dx. I can't do an integral something to u dx. That doesn't make sense. Yeah? So I have to get rid of the dx and get it into a du format as well. So I'm going to get an integral in terms of u. I'm then going to do that integral, and then I'm going to convert it back into x. That's essentially my process, okay? I've written the steps out over here, but essentially, I think it's just quite easy if you just follow the logic, okay? What we're trying to do. First thing, find the substitution. Like I said to you, in most cases they'll give it to you, so I've given it to you. That's your substitution. Okay? Let's write this down as we go along. So, first thing, start with the substitution. Okay? U equals 2x plus 5. Step 2, find du by dx. So let's just differentiate this. Let's differentiate it. What is du by dx? If I differentiated that with respect to x, what do I get? 2. Everyone happy with that? Now, I know, coming up in a few steps, one of the things I'm going to have to do is replace this dx, aren't I? So let's just make dx the subject right now before we go any further. So if I just wanted to rearrange this, Is everyone happy? I take the dx up there and bring the 2 down here. Is everyone happy that I get dx equals du over 2? Everyone happy with that? That's step 1. Figure out what that is. So that's step 1 and 2. Rearrange to find dx. I found dx. Next step, rewrite my question. Okay? Rewrite my question. So let's start with this u again. Let's make x the subject. Is everyone happy? Just from here, x equals u minus 5 over 2. I don't need to work that out, right? Everyone happy with that? Okay. Now, it says rewrite your question in terms of du. Now I'm going to say, okay, take all these things and substitute it into the original. So let's go and do that. So the integral, okay, I forgot what the question is now, of x, 2x plus 5 square rooted. So the integral of x square root 2x plus 5 dx equals, what's x equal to? Just look back through the things I found. What is x equal to? Yeah, and it might just also be a sensible thing just to, because these are the 2 things we're going to come back to all the time. So u minus 5 over 2. Got that bit? Right. What is 2x plus 5 square rooted equal to? Yeah, because 2x plus 5 is u, right? So what would the square root of 2x plus 5 be? Wouldn't it just be square root of u? Okay, and I'm just going to write it like this. You'll see why in a second. That's the square root of u, right? And what's dx equal to? Du over 2. Can you see why it's called integration by substitution? Basically what I'm doing is getting rid of all my x's, substituting with u's. And I can do this. It's a miracle. So I can now say, let's just multiply this out. That's u multiplied by u to the half. Is that u to the 3 over 2? Yeah. And then minus 5u to the half. And then you've got a 2 times 2 at the bottom, makes 4. Yeah, so that's that. And then my du, sorry guys, I forgot something. You make sure you put the integral sign in. I haven't done the integration yet, have I? My du still stays there. So can you see what I've done? I've taken an integral that I couldn't do and quite simply converted it to a, well, that's a straightforward integral. You've learned how to do that in the start of year 12. Yeah, you can all do that integral. Okay, let's do it. So add 1 to the power, divide by the new power. So this is u to the power of 5 over 2 divided by, now you're going to divide by 5 over 2. So that 5 over 2 is going to come underneath the 4 divided by 5 over 2. Is everyone happy that that would essentially become 1 over 10? Because there's already a 4 there, and I'm going to divide that by 5 over 2. So that 2 is going to go all the way to the top, isn't it? Because if you divide by a fraction, you're going to end up there. So that's 2 over 20, which is, that 5 will multiply by that 4 to give you 20. Yeah? If you're not sure about it, just use the calculator and do it. Yeah. And then, minus, add 1 to the power, divide by the new power. So you've got 5 over 4 over there. Add 1 to the power, u to the 3 over 2 divided by 3 over 2. Would it be easier if I presented it like that? Does this get complicated? Okay, fine. In which case, what I'll do, what might be an easier way of doing this? Okay, this hope everyone will get this one. Okay, so this is a quarter. Everyone's happy with the quarter, and then 5 over 2. Does that make more sense? Yeah, sorry, maybe I should present it like that instead. Yeah. Now all I need to do is to simplify that. So, okay, that is now equal to, well, that's 1 over 10, if you do the maths, u to the 5 over 2. And this one is going to be 10 over 12, so 5 over 6. Okay, here's my answer. But hold on. I said, what's the integral of something, something, something x? You've given me an answer in u. What do you think the last step is? Yeah. So we know what u is equal to. Go right back to the beginning. U is just equal to 2x plus 5. U is just equal to 2x plus 5. So what I need to do is to say, okay, that's 1 over 10, 2x plus 5 to the power of 5 over 2, minus 5 over 6, 2x plus 5 to the power of 3 over 2, plus c. And you can see what looks like a really straightforward integration to start with has produced quite a long answer, hasn't it? Yeah? But essentially what I've done is I've taken an integration that I cannot do, converted it into an integral that I can do, and then said, okay, let's try it. Let's see what happens. Yeah? Is everyone okay with that? Yeah? What I'm going to do, I'm going to write the next question up so I have much more space. I don't like this stuff on the left-hand side. Right, we okay with that? Okay, let's try another question. So, we're using the substitution u equals 2x plus 1 to find the integral of that thing, okay? So I'm just going to, if it's okay, substitution u equals 2x plus 1. And I need to find the integral of x into 2x plus 1 to the power of 5. X into 2x plus 1 to the power of 5. Okay? Right, so what was the first thing I had to do? What was the first thing I did when I wanted to do this? Yes, so differentiate this one. So du by dx equals 2. So what's dx equal to? Sorry, yeah, what's dx equal to? Put a box around that. We're going to come back to that. Now, take this one. Is everyone happy that if I start with u equals 2x plus 1, x is just equal to... Huh? Everyone happy with that? Yeah, fine. So now I've got everything I need, right? I've got everything I need to do the integral. I found my x. I know what 2x plus 1 is. And I know what my dx is, which I forgot to write over there. Okay, so what I'm going to say next is that the integral of x into 2x plus 1 to the power of 5 dx equals, let's do this step by step. What is x equal to? U minus 1 over 2. 2x plus 1, what is 2x plus 1 equal to? U. So what's 2x plus 1 to the power of 5? U to the power of 5. And what's dx equal to? Du over 2. And that is another integral that I can do quite easily. Because that's the integral of, okay, if I just multiply this through, can everyone see that's u to the power of 6 over 4? And can everyone see that's u to the power of 5 over 4 as well, with a minus sign? Yeah? So we say, okay, let's do that. Well, add 1 to the power, divide by the new power. You can all do that. So that's u to the 7 over 7 4 is 28. Minus what would that be? U to the 6 over 24. All right? Yes. Add 1 to the power, divide by the new power. 6 fours are 24. Plus C. Now what do I need to do? Last step. Yeah. And what's U equal to? Well, I know U equals just 2x plus 1. So it's perfect. So I say, okay, it's 2x plus 1 to the power of 7 all over 28 minus 2x plus 1 to the power of 6 over 24. And then do not forget my good old friend, the constants of integration. Everyone happy with that? Yeah. Where this gets tricky is when you do trigonometric substitution. That's what we're going to spend most of the time on. I think there's 1 or 2 more examples coming up. Okay. Now, I just want to show you one other thing. Okay. And I'm going to go back to the first question and show you another way of doing this. Any questions so far? No? Okay. So the first question we had was this one, wasn't it? X, find the integral of x 2x plus 5. That was the first question we did up here. X 2x plus 5. Yeah? So I'm going to go back. I'm just going to write this out in full again. So I want to know the integral of x square root of 2x plus 5 dx. Using the substitution, u equals 2x plus 5. It is not the only substitution we can use. And if you look at this question, they've said to you, use the substitution u squared equals 2x plus 5, okay? If a question comes up like this, you have no choice, because it says use that, so you have to use it. If it says using this substitution or otherwise, you can choose, right? But as a rule of thumb, don't ever choose something that's not there. There's a reason they've told you to do it that way. Do it that way, okay? So using the substitution u squared equals 2x plus 5. I'm just going to show you, we're not going to do this whole question, but we're going to get started to the point where we get to the integration. And you will obviously get the same answer, won't you? Because it's the same integral, right? But you'll see it's quite different how we do this. Okay, so first step, find, so using this substitution instead, first step is to find du by dx. How do you do that?
Use that square root first.
You can square root first, can't you? And go through that. There is another way. We did that last year. Oh, I hope you've done it last year. Parametric differentiation? No, does that ring a bell?
We might have done it, but
Okay, fine. So the idea you differentiate just normally like with the u, put the u by dx at the end. So if I differentiate this, this would become, well, what would u squared ordinarily differentiate to? But I use, and what would that ordinarily differentiate to? 2. Does that ring a bell? What did you call that? You just didn't know the name. Yay, there we go. Okay, so yeah, does that make sense? Yeah. So I'm differentiating with respect to x. So what I do is I just do it like it was a u, but I multiply by du by dx. Okay. And here, I still need to find dx. So from here, I find dx. So dx is quite simply just that goes up there, that comes down here. That 2 will cancel with that 2. So dx equals u du. Okay, let's write this down as we go along. Okay, so that was the first step. The next step was to figure out what x is, right? So from here, let's figure out what x is. And I apologize for the presentation. There's not enough space on this board. So u squared equals 2x plus 5. So is everyone happy that x is just quite simply u squared minus 5 over 2? Everyone happy with that? Okay. Now, let's just go back and do our normal substitution. So we do our normal substitution. We're going to say x, the integral of x root 2x plus 5 dx equals, right, well, what's x equal to? U squared minus 5 over 2. Therefore, what's the square root of 2x plus 5 equal to? U. It's not u squared, is it? U squared is 2x plus 5. So the square root of 2x plus 5 is u. And what's dx equal to? U. That'd be easier. And can you all see the answer now? Can you all see how that's a nice straightforward integration, isn't it? Because that's just the integral of, well, what have I got outside here? U times u? U squared. U squared times u squared? U to the 4. So it's u to the 4 over 2 minus 5u squared over 2. Now, I'm not going to finish it, but from here you can all integrate this. You've known how to integrate this since the start of year 12, okay? So, and then you just go back and change your substitution. When you get your answer, you just substitute back in, and you'll get the same answer as we did here. You will get that answer there. U to the 5 over 2 will be that one. And if you kind of think about it, you can see that's going to happen, because when you integrate u to the 4, what do you get? U to the 5. But then don't forget, when you do the substitution, you've got to put a square root back inside, because it's going to be u to the half. And that 5 and that half will give you 5 over 2. Okay? Is everyone happy with the principle? Yeah? This is how we do this. Yeah? Okay. What I'd like you to do is, I think on the next slide I've got a few questions. Where do I go down? Okay, well, let's. Do you want to have a go at one yourself? Okay, can you try this one? So using the substitution, u equals the square root of x minus 2. Okay, I'll just write it out properly. So u equals the square root of x minus 2. I want you to find the integral of x over the square root of x minus 2. And find the integral of x over the square root of x minus 2 dx. Okay? Now, first of all, before you start this question, why can you not do like none of the bottom or something like that? Yeah, x minus 2 differentiates just to 1. I haven't got 1 at the top, I've got an x. If I had a number, it'd be fine. I'd just add 1 to the power, try it. Or no, I do none at the bottom, see what happens. But I can't do that, so I have to do substitution, okay? So remember the steps. Firstly, find du by dx. Okay? Then make the substitution, and then see where you go from there. It's a bit trickier, this question, because u, to differentiate this, you have to write this as this, don't you? Yeah? Leave it like that. Have a go at it. In fact, you know what? We'll do it together. Let's do it in our books. We'll do it together. This is much trickier. Okay, so let's differentiate this. I get du by dx. Let's differentiate this. What do you get when you differentiate this? What do you get when you differentiate this? Yeah, you bring the power down. Take 1 away from the power. Yeah? Everyone happy with that? Yeah? Okay. Now, so we need to find dx from here. I'm just going to rewrite this for a second. Du by dx equals, is everyone happy that when you do power minus half, it's 1 over 2? Everyone happy with that? Yeah? So now let's figure out what dx is. So dx is going to be 2 root x minus 2 du. Right, any questions? Okay, so next step, let's figure out what, from here, I need to figure out what x is, don't I, to make that substitution. So let's start over here. U equals the square root of x minus 2. Okay. So u squared equals x minus 2. Sorry. And this is where it's going to get a bit tricky. So is everyone happy that x equals u squared plus 2? Can anyone see a potential problem coming our way? Can you see a potential problem? Okay, let's do this. And once we do it, you'll see the problem. So let's just go for it. So the integral I was actually trying to do was x over x minus 2 dx. Right? So let's do it. So it's the integral of x over the square root of x minus 2, dx. Okay? Let's just do it step by step. What is x equal to? U squared plus 2. Over, what's the square root of x minus 2? Just u. What is dx equal to? I need to get rid of that dx. What's the problem? Yeah, I can't integrate x with respect to u. I'm not allowed to do that. If I said, what's the integral of 5x dz, that doesn't make sense, does it? I have to integrate with respect to a variable. There are ways of doing these things, but at school level, it's not, we're not going to go into this, right? I've got x, and I'm trying to integrate it with respect to u. I can't do that. Not allowed. Can anyone see a little simple way of getting rid of that x minus 2? That's just u, isn't it? It's just that. So sometimes when you do integration by substitution, and this particularly happens when it's trigonometric, as we'll see in a few moments, sometimes you end up with this thing that you're like, oh, you sometimes have to get that substitution back in. Remember, you must have it as a whole series of variables with respect in u, du. You cannot have x's and other things flying around. Numbers are fine, but no other variables flying around in there. It must be all u's. So if I just write this out again ever so slightly differently, this is essentially, well, let's just do it properly. This is u squared plus 2 over u times by 2. And what did we say the square root of x minus 2 was? U. And actually, hey presto, look. So the whole thing, sorry, I forgot my integral sign there. The whole thing is just reduced to the integral of 2u squared plus 4 du. which you can all do. That's 2u cubed over 3. Plus that. Everyone happy with that? And then you substitute back in. So remember, u was equal to x minus 2 to the half. So let's substitute back in. So that is now 2 over 3 x minus 2 to the power of 3 over 2 plus 4. Let's see. You okay with that? Yeah? Do you feel like having a couple of questions? Okay. Right. I've circled, I think it was 2 or 3 on this next page. Has everyone got that down? Yeah? Okay. Can you have a go at these 2 questions? So I've got, can everyone read that? Yeah? Okay. Have a go at those 2 questions, please. The substitution is given to you. So in the first one, it's just u equals 1 plus x, and the second one is u equals 3 plus 2x. Okay, once you've done those questions, we'll move on to some trigonometric. We'll deal with limits as well later on, but first we'll move to some trigonometry. 2 at the top in the numerator. Yeah, that's right. Did you get that as your integral? Yeah? Good. Not making mistakes. So it's like hailstones, doesn't it? I really can't decide what it wants to do. Right, so the next one, integral of x over 3 plus 2x to the power of 5. We'll just do the, I'll do it over here, x. 3 plus 2x to the 5th power. Did we get that far? U to the 6 over 4 minus 3/4 u to the 5. Yeah, I won't finish it off. You can all do that integration. It's straightforward and then do the substitution back from there, yeah? Okay, good. Right, any questions so far? Okay, these are the straightforward questions. This would be no more than, I don't know, 4 or 5 exam marks or something. 3, possibly even 3 or 4. It's not going to be difficult. It's very straightforward. Where it gets tricky and where it gets a lot harder is when we start introducing trigonometry. Okay, and this is the sort of next sort of questions of the next sort of questions we're going to have a look at, which is when we're doing integration of trigonometric functions. Okay, so here I've asked you, and I'm just going to write it using substitution u equals sine x plus 1. I'm going to put this on a new slide because I need to be able to see a bit more than that. U equals sine x plus 1. So using that substitution, u equals sine x plus 1. I want you to work out what the integral of, it is sine x cos x 1 plus sine x cubed is. Sine x cos x 1 plus sine x cubed. Okay, let's write that down. We're going to do these together. Do it in your books, please. And again, we're going to just have to do a few tricks of the trade here. There's a few little common things that happen all the time, which we just have to be aware of. Okay? So, before I start, I'm just going to check I've written it down correctly. Sine x cos x 1 plus sine x cubed. Sine x cos x 1 plus sine x cubed. Yeah, that's correct. Cos x sine x doesn't matter. Okay? Right, so the first few steps don't change. Okay? The first step, figure out what du by dx is. So let's differentiate this. Du by dx. Well, what does sine x differentiate to? So let's rearrange this for dx. Dx equals du. Okay, and immediately, can you see one problem that we're going to come across in the future, coming up in a few steps? There's an x there. Okay, sometimes this happens. Don't worry about it because you'll see why in a few steps. Okay, next step. Well, that's what sine x is, right? I've got to figure out what. Sorry, that's what u is. I've got to figure out what sine x is and what 1 plus sine x is to do my substitution. So think. I've got to substitute all of this, don't I? Sorry, I forgot a dx over here. I've got to substitute all of these. Well, I can know what sine x is, don't I? Yeah. I don't know what cos x is because, well, how do I convert that to a cos x? But I do know what that is, don't I? Yeah. So what we're going to see is just do the substitution. Let's see if something happens here. So the integral of sine x cos x 1 plus sine x all cubed dx equals, well, what is sine x? Go back to my substitution. What is sine x? Sorry? U minus 1. Everyone happy with that? From here, sine x is just u minus 1. So that's u minus 1. What is cos x? Yeah, I've got to use the substitution here. I haven't got anything, have I? Okay, don't worry. Leave it. Just write it as cos x for a second. Okay, just leave it there for a second. Bear in mind, we've got to come back to this. What is 1 plus sine x? U. So what is 1 plus sine x cubed? What is dx? Du over cos x. And can you see now how it solved my problem? Because I've got a cos x in the numerator and a cos x in the denominator. You saw that happen earlier on, didn't you? When it cancelled or we made a substitution. Okay? In trigonometric integrations by substitution, this happens all the time. So sometimes don't rack your brains for too long thinking, what am I going to do? What am I going to do? I can't get rid of this cos x. Just put it in, and normally it'll cancel out. If it doesn't cancel out, you do have to go back to the drawing board. Yeah, you do have to go back to the drawing board. You can convert sine x into cos x using an identity. Because cos squared x plus sine squared x equals 1. So you can do it, but it's quite a long-winded process. Yeah. So I've converted this ridiculously long, the integral of sine x cos x into 1 plus sine x cubed dx. I've converted that huge integral into integral of u to the power of 4 minus u cubed. There you go. That ridiculously long integral has just become this. So let's work it out. So that's u to the 5 over 5. And then last step, well, what's u equal to? Oh, so that's sine x plus 1 to the power of 5 over 5 minus There you are. It's really quite satisfying when this huge long thing just becomes something so simple. I see your faces. What's Mr. Happy want to give now? Oh, terrible. Right, any questions? No? Okay, let's see what's next. Right, we'll come back to that one. Let's do another trigonometric one. Right, so this is a definite integral. So we'll have a go at this one. So this is the integral from 0 to pi by 2 of cos x root 1 plus sin x. Okay, let's write this down. So it's the integral from 0 to pi by 2 of cos x square root 1 plus sin x. Using the substitution, u equals 1 plus sin x. Okay. Sorry, that just looks like a complete mess, doesn't it? Diatribe. Cos x 1 plus sin x dx using the substitution u equals 1 plus sin x integrated from 0 to pi by 2. Okay, this is a definite integral. Happy with that? So there's one extra step I need to do in this process. The first couple is exactly the same. First thing is exactly the same. Start with u equals 1 plus sin x. What is du by dx equal to? Cos x. So what's dx equal to? And just stop and think for a second. When I put that dx into here, what's the great thing that's going to happen? Yeah, because I've got a cos x in the denominator, and that's going to cancel. So all I need to worry about is this thing. Yeah. Okay. So let's think about the substitution in a second. Okay. Step one, exactly the same. No different whatsoever. So I've identified what my dx is. Okay. Step two, we're going to change the limits. Because when I do an integral in terms of x, I have limits in terms of x, don't I? This really, although we don't write it, this really says the integral from x equals 0 to x equals pi by 2. You know, like when you see all the questions about find the area, it will say find the area between the curve, between the lines x equals 3 and x equals 4. So although we don't write it, these are x numbers. These are x equals 0 and x equals pi by 2. But hold on, I can't do that. I can't do an integral with u and put in x limits. So I'm just going to change them, okay, using my substitution, u equals 1 plus sin x. So let's next step, maybe write this down this time, change limits. Okay, so u equals 1 plus sin x. So here, what is x equal to? So just substitute it. When x equals 0, u equals 1 plus sine 0. What's sine 0? Sine 0 is, please, we don't need a calculator, folks, come on. 0. So 1 plus 0, 1. Now let's stick in the next one. When x equals pi by 2, u equals 1 plus sine. Well, what is sine pi by 2? Sine of 90? 1. So 1 plus 1, 2. Now we do exactly what we did, but we remember to change the limits as well. Okay? So it's the integral from 0 to pi by 2. What time does lesson finish? That's a great answer. Let's get finish this off, okay? That's actually a really good answer. Who said that? That's clever. I like it. 3 minutes ago. Okay, right. So the integral from 0 to pi by 2. So I have the integral from 0 to pi by 2. Okay, write this down, please. Of cos x root 1 plus sin x. Dx equals. Now, when it was 0, what did 0 convert to when I did it in terms of u? 1. So instead of 0, I write 1. What did pi by 2 convert when I converted it in terms of u? 2. So I write 2. And then I've got, let's just do cos x. Leave it for a second. Leave the cos x, okay? Because we'll hopefully, this happens so often in the trigonometric world. If you don't leave it, it will cancel itself out. Right, what is the square root of 1 plus sin x? U to the half. Yeah, so remember, the substitution is u equals 1 plus sin x. So the square root is u to the half. And then what is dx equal to? Du over cos x. And hey presto, look, that one and that one cancel. So I've literally converted my entire integral, this big, long, crazy thing over there, I've literally converted it to the integral of u to the half. So that's the integral from 1 to 2 of u to the half du. Okay, so let's do it. Let's just finish this question off. So that is u to the 3 over 2 over 3 over 2. Don't forget to change the square brackets because we're using limits. And it's from, what is it, from 2 to 1. Or 1 to 2, really, I should say. So that's 2/3 u to the 3 over 2, evaluated between 2 and 1. So u to the power of, 2 to the power of 3 over 2 is 2 root 2. Yeah, so let's just write that out properly. Everyone see u to the power of 2/3? Oh, sorry, 3 over 2 is u cubed, which is 8. Square root of 8 is root 4 times. Let's write it out. It's 2/3 2 to the power of 3 over 2. So that's the upper limit. Take away the lower limit. Well, if you just put 1 in there, what do you get? What's 1 to the power of 3 over 2? 1. So you just get 2/3, don't you? And that, this there, that's root 8 or 2 root 2. So it's 2 over 3 times 2 root 2 minus 2/3. Yeah? I suppose the only way that would really simplify is 4/3 root 2. Yeah, I don't think there's an easy, simple way of doing it, but you could probably factorize out a 2/3 from there. So if I factorize out a 2/3 from there, I'm left with 2 root 2 minus 1. Do I need to substitute? Well, I don't need to do the last bit, do I? Substitute back into x. Because it's a definite integral. My answer is just a number. Because I've had to do a substitution of my limits. Yeah? If it's an indefinite integral, you must remember the last step. After you do the integration, you must substitute back in for the x. Because I asked you a question of an integral of x, you can't give me an answer in u. Yeah? To use that same analogy I started with, if I ask you for a distance from here to that wall in centimeters, you can't give me an answer in meters. You've got to convert it back to what I want. Yeah? I know what I want, but the examiner wants. Any questions? Right. Homework is due tomorrow. Listen. Homework is due tomorrow. The exam pack, if you don't have an exam pack, please check and collect one now. I shall give you the answers to that on Friday, but on Monday. Please do make sure you have done it. Okay? Right, let's pack up, and then I shall see you outside.